Okay, so here's the warm-up for 9.5. It says plot the point and find 3 additional polar representations of the point using negative 2 pi is less than theta, which is less than 2 pi. Then find the rectangular coordinates for the point. So there's kind of 3 things in one here. The first one is the graphing. So if I were to pull in a graph, it says 4 and 2 pi over 3. 2 pi over 3 is actually along this line here. That's 2 pi over 3 because it's less than 1 but bigger than a half, remember? And then I'd go out to 1, 2, 3, the 4th rung. So these rings are like, there's a dark one and then a gray one doesn't count as the ring for a 1. So just pay attention to how it's labeled. I will give you on Monday it's actually like a scrap sheet of paper that you can print ahead of time or you can put into Notability, and that's how you'll do your work. Mary Angel, no, your test is Wednesday, not Monday. All right, so now that's my plotting of the point. The second thing says find additional polar representations of the point, and I need 3. So remember my options here are to keep R the same, take theta and add and subtract even multiples of pi, like 2 pi, 4 pi, so on and so forth. Or change R to be negative, take theta, add and subtract odd multiples of pi. So let's go with the even ones. If I take 4 and keep it the way that it is, and then I take 2 pi over 3, and I add 2 pi to it, or 6 pi over 3, I get 8 pi over 3, which is too big for this range, so I can't use it. So I'm going to try 2 pi over 3, subtract 2 pi, which would be 6 pi over 3. And I get negative 4 pi over 3, which is in between negative 2 pi and positive 2 pi. So that's the first coordinate point that works. And you can test it by going negative 4 pi over 3, which would actually be that same angle, going to 4, plotting your point. They should be the same points. So that's the first one. Now, if I subtract 2 pi again, I know it's going to be too big, or too small. So I know I'm switching to the negative. So if I did negative 4, and I take my original angle, 2 pi over 3, and I add pi to it, this is 3 pi over 3. 5 pi over 3 is what I get, which is less than 2 pi. So I'm going to use it. 5 pi over 3, which is actually here. Here. But remember, if the R is negative, we count away from it, and it puts me back on the same spot. Now I need one more. So I'm going to take 2 pi over 3, and I'm going to subtract 3 pi over 3 from it, and I get negative pi over 3. That's in between negative 2 pi and positive 2 pi, so that's my third coordinate point. There's my 3 additional representations of that point. Okay, then it says to find the rectangular coordinates for the point. So I'm going from polar to rectangular, which means I'm going to take the R, multiply it times the cosine of theta. Well, here, let me write out that first. R times the cosine of theta. That's going to be my x value, and then R cosine, or sine of theta. Your homework asks you to order these in order from least to greatest. So if you look at the 3 angles here, the smallest one is negative 4 pi over 3. So this one would have come first. Then comes negative pi over 3. Then comes 5 pi over 3. So if I was to enter this in the homework, it would have been first, second, third, like that. So I know that got some of you. You just have to go in order from smallest to largest on the theta. Okay, back to the conversion. So R here is 4 cosine of 2 pi over 3, and then 4 sine 2 pi over 3. So if I had my unit circle, I would know that 2 pi over 3 has the coordinate point negative 1/2 and root 3 over 2. And then I would just plug in. Cosine is the x, negative 1/2. Sine is the y, root 3 over 2. And I'd get negative 2, this goes in twice, and 2 root 3. and it's an XY coordinate. So there's the conversion. All right, number 2 says plot the point given in rectangular coordinates and then find 2 sets of polar coordinates for the point. So now we're going to do it in rectangular coordinate grid. So I get negative root 3 and negative 1. Root 3 is about 1.7. So this is like saying negative 1.7, negative 1. That point would be there. So I know it's in the third quadrant already. Now I want to find 2 sets of polar coordinates. So I have to go from rectangular to polar. And to do that, we say r squared equals x squared plus y squared. And then we say the tangent of theta equals y over x. So r squared would equal negative root 3 squared plus negative 1 squared. Negative times negative becomes positive. Root 3 times root 3 is just 3. Negative 1 times negative 1 is 1. R squared would equal 4, and r would equal 2. That's the first part. Second part is your theta. Tangent of theta would equal negative 1 over negative root 3. So tangent of theta would equal 1 over root 3, which gets rationalized to root 3 over root 3. Now, if I had my unit circle, I would hopefully remember that the root 3 over root 3 happens at over 6's, right? Because we need 2 3's to make a 6. So it happens at pi over 6 over here. It would be positive there. And it's also positive at 7 pi over 6 over here. And because we originally plotted this point in the third quadrant, I know that's the one I want to pick. So theta is 7 pi over 6. So r theta is 7 pi over 6. And then it says find 2 sets of polar coordinates. And it gives me a range of 0 to 2 pi this time. So if I keep r the same and I take 7 pi over 6 and I add 12 pi over 6, it's too big, so I can't do that. If I subtract 2 pi, it goes negative, which it wants me to keep it positive, so I can't do that. Which means I have to use the other method. Change r to be negative. If I add pi, it's going to be too big, but if I subtract pi, 7 pi over 6 minus 6 pi over 6, I get pi over 6. And there's the other coordinate that I can use to describe the same point that would fall between 0 and 2 pi. Okay, here's the review for your test. So, this should actually just say 9.5 because your test is just 9.495. So 9.4 is your parametric equations. Remember, there were 3 different types of questions from 9.4. The first is graphing. So you're going to receive something almost exactly like this. The picture of your t-chart and the graph coordinate grid are exactly the same. And it's going to tell you to graph the parametric equation, and it's going to give you a range. So if I gave you, for example, if I gave you negative 2 to positive 2, then I'm going to take and plug those in for my t values. Negative 2, negative 1, 0, 1, and 2. And I'm going to first plug that into x. So 2 times negative 2 plus 3 is negative 4 plus 3, negative 1. 2 times negative 1 plus 3, negative 2 plus 3 is 1. 2, 0 plus 3 is 0 plus 3, which is 3. 2 times 1 plus 3 is 2 plus 3, or 5. And 2 times 2 plus 3, 4 plus 3, or 7. Then you want to go back and do y's. So y would equal 4 minus negative 2 squared, which is 4 minus 4, or 0. 4 minus negative 1 squared is 4 minus 1, which is 3. 4 minus 0 squared, 4 minus 0, which is 4. 4 minus 1 squared, 4 minus 1, which is 3. And 4 minus 2 squared, 4 minus 4, which is 0. Then you're going to give me those coordinate points as x, y's. So you're going to fill in this chart in its entirety. Negative 1, 0, 1, 3, 3, 4, 0.5370. And you're going to plot those points. Negative 1, 0, 1, 3, 3, 4, 5, 3, 7, 0. And you're going to draw this curve, and you're going to make sure you give me the orientation arrows, which are going to point towards the biggest T. Something just like that. So don't forget your arrows. So this kinds of question is going to actually ask you to take a picture of this answer. So it's going to give you a little box to do your work, to get your T-chart, to get your graph. You're going to take a picture of it, and you're going to submit a picture to that individual question, not as a file upload, but actually as an embedded picture in the text entry box, which we will review how to do that on Monday. Okay, now the next one is eliminating the parameters. So remember with these, you're getting rid of T. So I want to take one of the equations, and it doesn't matter which one, make it the easier one if you can. Solve for T and then plug that into the other equation. So if I look at the first one, I don't have the square, which is going to make this easier. I would get x minus 3 equals T, and then I'm going to take x minus 3 and plug it in to the T. So I get y equals x minus 3 squared minus 5. Expand that. X squared minus 3x plus 9 minus 5. And then just combine your like terms. Oops, 6x. And there's the equation. If it had asked you to graph, which I won't, if it had asked you to graph that, it would be a parabola. And it just doesn't have the T anymore, so you don't have the orientation on the graph. It's an approximation of what it would look like, but it's not exact. All right, last one in parametric says finding the parametric equation given one parametric and one, but there's just one of those, rectangular. So in this case, you're gonna have one equation that has an x and one that doesn't. Oh, sorry, has a t and one that doesn't. And your result is actually two equations that both have the t. So this is actually part of my answer. If it wasn't solved for x, let's say it said t equals x, x minus 3, let's say it said that instead, then I would solve it for x first, and then I would take what it equals and plug it into the other equation in place of the x. So y would equal t plus 3 plus 4, and y would equal t plus 7. And there's your second equation making your parametric system. That's what the answer's looking for. Zoom in on that first. These are just some examples. It says to graph r theta, if it's 2 and 2 pi over 3. So your graph is going to get given to you just like this one is. If I want to graph that one, so let me color coordinate it. I'm going to make it red. 2 and 2 pi over 3. This is 2 pi over 3. So out to the second ring would be there. 2 and 2 pi over 3. Then, let's switch color. This one to negative 2 pi over 3. Now I'm going to work opposite direction. This would be 1 over 3 pi, which means I got to go to the second one here. This would be negative 2 pi over 3. Go to 2, put a point. Then comes negative 2 pi over 3. So I go back to where 2 pi over 3 is, which is up here, and instead of going towards it where the 2 is, I'm going to count away from it, and that would be negative. Last one, let me actually change the color on that. So let's make this the blue one. Negative 2 pi over 3, which was back over here. Negative 2 means instead of going in this direction, I'm going to count away from it, and it'd be there. Remember that these are not rays, these are just coordinate points, so all you need is a point there at the end. Now it says find additional points. So let's just do this with the first one. Let's just take our first one, and let's say it gives me the restriction of negative 2 pi to 2 pi. I was going to pay attention to that restriction. If it said 0 to 2 pi, that's obviously different. It's going to cut that restriction in half. So we have two options here. One is keep r the same, take theta and add or subtract even multiples of pi, like 2 pi is what we normally start with, or change the r, take theta, add and subtract odd multiples of pi. So let's say I start with 2 and 2 pi over 3. Okay, so the first thing I want to do is test my 2 pi. So if I kept r the same, it'd be 2. If I took 2 pi over 3 and added 2 pi, which would be 6 pi over 3, I get 8 pi over 3. That's too big. So now I want to try subtracting 6 pi over 3, and I get negative 4 pi over 3. And I think I grabbed the same one that was in the warm-up, but you'll understand it, okay? Then the other option is to change the sign. So I'm going to make it negative 2, and then take 2 pi over 3, add pi to it, or 3 pi over 3, and I get 5 pi over 3. That's less than 2 pi, so I can keep it. And then take negative 2, this time subtract pi, or 3 pi over 3, and I get negative pi over 3. There are my 3 additional representations of the same point. If it wanted it in order of least to greatest, negative 4 pi over 3 is the smallest. That would go first. Negative pi over 3 is the second smallest, and then they're the middle, and then the 5 pi over 3 would be the last one in order from least to greatest. Okay, now let's talk conversion. So we did this on the warm-up, but we're going to do it real fast again. If we're converting from polar to rectangular, this would be without a calculator. These answers will be kept exact. To go from polar to rectangular, my x equals r times the cosine of theta, and my y equals r times the sine of theta. And then my answer is going to be in xy format. If it's rectangular to polar, then my r squared equals x squared plus y squared, and my tan theta equals y over x. And my answer is going to be r theta, whatever that coordinate point is. So here's an example. 6 and 7 pi. Oh, these are actually, this is not unit circle base. So let's make this 4. Let's make this unit circle base so we can see what that looks like. And same here. And then we'll go back on the next slide and do the with a calculator. So 6 and 7 pi over 4, this is in our theta. So this is in polar, and I want to go to rectangular. I would do 6 times the cosine of 7 pi over 4, 6 times the sine of 7 pi over 4. So you're definitely going to want your unit circle. On your unit circle, you'll see 7 pi over 4 is in the 4th quadrant. Coordinate point there is root 2 over 2 and negative root 2 over 2. So 6 times root 2 over 2, 6 times negative root 2 over 2. This becomes 3 root 2, negative 3 root 2. If it's 3 r squared equals, or negative 3, sorry, negative 3 squared plus 3 squared. R squared equals 9 plus 9. 18. R would equal square root 18, which is 3 root 2. That's your radius. Then comes tangent. So tangent of theta would be y over x. Negative 1. Tangent is negative 1 in 2 spots. 3 pi over 4 and 7 pi over 4. I want to pick the one that has a negative x and a positive y, which means second quadrant. So theta is 3 pi over 4. So r theta is 3 root 2, 3 pi over 4. All right, so for these, you're gonna need to use a calculator. I'll show you again how to use it with a graphing calculator, and then I'll walk you through how to use it with scientific, but I don't have a scientific at home with me, so you're gonna have to try to practice on your own. First things first is that your calculator needs to be in radians. Otherwise, you'll get the completely wrong answers and not know why. So if I'm going from rectangular to polar, I'm gonna pull in the video. On a graphing calculator, okay, I'm gonna hit clear. I'm gonna make sure I'm in radians, which I am. I'm gonna go second apps, and I'm going rectangular to polar. I gotta do it once for R. 1.6 comma negative 7.2. There's the first one. So the R equals 7.38. Repeat that. Second apps R to P theta. 1.6 comma negative 7.2. And theta is negative 1.35. So my answer R theta, 7.38, negative 1.35. I'll walk you through how to do this with the scientific after I do the next one. So polar to rectangular, second polar to rectangular X, negative 3.2, comma 4.5. My X is 0.67. Repeat that process, except doing the Y this time. Negative 3.2, 4.5, Y 3.13. So my X, Y, 0.67 and 3.13. Okay, so if I was to do this on a scientific calculator, then the rectangular to polar, I would have to do R squared equals 1.6 squared plus negative 7.2 squared, and then square root what you get from that, and you're going to get the 7.38. And then I would have to do tangent of theta equals y over x, negative 7.2 over 1.6, and I would do tan negative 1 of that, and I get theta equals that negative 1.35. So what's going to happen if you use a really basic scientific calculator, you're going to have to divide negative 7.2 by 1.6, it's a point, 0.6, hit enter, then hit second tangent to get your theta. To do the polar rectangular with a standard scientific calculator, you're going to have to take x, negative 3.2, multiply it times the cosine of 4.5, and then you're going to take negative 3.2, multiply times the sine of 4.5. Again, you got to make sure it's in radians, and if it's a basic scientific calculator, you'll have to do 4.5, then hit cosine, then multiply it by negative 3.2, and you'll get the 0.67. Take 4.5, hit sine, then take that, multiply it times negative 3.2, and you'll get 3.13. All right, that wraps up what you are going to need to know for your test. Again, make sure you're using a second device. So we're still going to use all the same rules. Second device. This time our audio is going to stay on. No muting. So please get in a quiet environment. You can use calcs and notes. And then you'll submit your work at the end, but you're also going to submit work for 2 questions that we'll practice on Monday. Have a good weekend. Is that what it was? Wait, 7 root 3 and negative 7, not root 3. Okay, so I think you got it right. You just got the wrong angles, right? So in order to get, this is rectangular, right? So to get the r squared, you did 7 root 3 squared plus negative 7 squared. That's 49. Wait, is that what I'm doing? Let me go back. Given rectangular. Yeah, find 2 sets of polar. Okay. This would be 3, and this would be 49. So that's 147 plus 49. 196. R squared equals 196, and r is the square root of 196, which is 14. So that's where the r comes from. And then to find theta, you have to do tangent of theta equals negative 7 over 7 root 3. Tan of theta. The 7's cancel, and I get negative 1 over root 3, which gets rationalized to negative root 3 over 3. So there's two tangents that are negative root 3 over 3. They're the over 6's in the second quadrant and the over 6's in the fourth quadrant. And because this original point would be positive and then negative, it means it would put it in the fourth quadrant. So that's why you don't pick 7 pi over 6. So theta is 11 pi over 6. So that's 1 coordinate point 14, 11 pi over 6. And then it asked 2 between 0 and 2 pi. So that's the one in between 0 and 2 pi that I can give with keeping r. If I add 2 pi, it's too big. If I subtract 2 pi, it's too small, which means the next thing to do would be to change the r. 11 pi over 6 plus pi is too big, but minus pi, or 6 pi over 6, is 5 pi over 6, and that's the second option. Good? All right. I'll have a little bit, we'll have like, there's a little bit of breathing room on Monday, so if you've got more questions, feel free to make sure you ask on Monday, okay? All right. Bye, Josh. Thank you.